We will start with our next topic. In the first unit, explain the error in chain surveying. So error means we have to apply some correction. How it will happen? It may be two possible choice in chaining. Is one based on the instrument, that is the used chain or the chain which we are going to use for measurement. It may be either too long or it may be too short. How it may be get elongated or it may be short based on our types of pull what we are going to apply, right? It may happen. Or if you are continuously using a particular chain for long period, it may get expand or it may be, right? So such defective may happen in the instrument, so that correction has to be made. This error is called the instrumental error. And next one, based on the nature, where we are going to use the chain, in that area what will be the temperature, and the chain was manufactured in a particular temperature. If both the temperature are same, there is no issue. If the temperature varies, then there will be a change in the length of the chain, right? So this is not in our hand, but the correction has to be made. But we have to put that thought there may change in the length due to the natural change in the length due to temperature, right? So these are the errors may happen in the chaining. Based on that, 5 standard error may happen. For that we have to apply the correction. So it is called the correction for the chaining. So now we try to explain or describe the importance of various correction for chaining. That is the outcome of this topic. So here the list you are seeing: erroneous tape length. Already we have discussed. Based on the instrumental error, the tape length may get elongated or short, too long or too short. Next one is the slope correction. We may consider we are measuring from point to point, so all the distance are horizontal. But if the terrain is slopy, the measured lengths are slope length. It is not equal to the horizontal length. That we are going to see in detail. Next is the tension or pull. Both the term are same. The chain manufactured in a particular pull such that it has a standard length of either 20 meter or 30 meter. But in the field, the applied pull by the particular person may differ. So based on that, the tape length may or chain length may get vary. So that error and that correction has to be made. That is the tension or pull. And already we have discussed about the fourth one, temperature. Based on the mean temperature and the standard temperature, the length of the chain may vary, since the steel has a property of expansion and contraction, right? And the sag will happen when the chain or tape is holded in the air from end to end, so it may form a catenary shape. So these are all the list of error may happen and the correction has to be made. If based on the tape, not the chain, tape, the tape length and the slope correction, erroneous tape length and the slope correction will be applied. There the expansion or the temperature impact is very less in the tape compared to the chain, right? And the pull also, there won't be. If we apply more pull, the tape will get teared off. So the pull correction mostly it won't be applied for the tape, so it is applicable for the chain only. So the two corrections only taken care for the synthetic tape. So here the accuracy we can achieve this 1:1000. When in using steel tapes, if only erroneous tape and slope correction are considered, the range of accuracy is 1:5000. Compared to the tape, here the range of accuracy is totally different, right? If the tension and the temperature are added into consideration, then the accuracy will increase to better than 1:10,000 or even to 1:20,000. So if the representative factor get increasing, the accuracy get increasing. So the sag correction is possible for both the tape and chain if both the ends are holded in the air, right? The formula to be applied for the erroneous tape length is, tape has a nominal length under certain condition. So in some book they may denote by E, in some book they denote by C. E represent the error, C represent the correction. If the error is negative, the correction is positive. You have to keep this sentence in mind for solving this problem. If the error is negative, the correction is positive. So here we try to explain the term. Here the LM is the total measured length. It may be 2000, 3000 or whatever the distance we totally measured, that is represented by LM. And LS is the standardization length, that is the actual length. Say if the chain what we are using, the 30 meter is too long, that length, how much long? It may be 5 centimeter long, then 30.05 is the actual tape length, that has to be substituted here, minus what was the standard length, that is nominal length, is the 30 meters. So 30.05 minus 30 divided by 30, that is the substitution. Based on that measure length, we will get the error. If the error is negative, you have to apply positive. If the error is positive, the correction is negative, vice versa. So the erroneous tape length have the both the type of error, right? Say example, a 30 meter chain was found to be 10 centimeter too long after chaining a distance of 1360 meter. Find the true distance. So the given data, the correct length of the chain is 30 meter, but the error here is 10 centimeter too long. Then what was the actual distance of the chain is 30 plus the 10 centimeter get converted to meter is divided by 100, so it is 0.1. The incorrect length is 30.10 meter. Based on the 30 meter chain consideration, we measured a distance of 1360 is the given data, but it is not right. We have to determine the right one, true length. So the measured length into the L dash is the difference, right? L dash divided by the standard. Here we can apply directly. 30.10 is the incorrect length, that is the L dash, divided by 30 meter, this is actual length, standard length, then we will get the true length. If we do 30.10 minus 30 by 30, we will get the error. Here we directly get the true length, right? So here in the previous we try to calculate the error alone, the formula gives, but here we directly calculate the true length since there is only one error, right? So we can directly apply this. See 1360 and here it is 1364.53. Sir, only 4.53 meter. If you convert to feet, it's approximately 13 feet. If 13 feet land, whether you will allow, anybody can take it. No, na? So these are the things has to be considered while doing the calculation part. So if such a erroneous tape length was used, based on that measured distance, if the area also calculated, that measured area will be have error. If the volume also calculated, that volume will be also have error. Then how we can calculate the true area, true volume? The square of the L dash by L gives the true area, and cubic of that L dash by L into the measured volume gives the true volume, right? So based on this we can calculate distance, area and volume, right? So how the standard length can be checked and the erroneous length? This is the standard length when it was marked standardly, and we are keep on using the chain. If we start measuring before starting a survey, it may get short or it may get elongated. If it is elongated, that is too long, you have to add that length when comparing, right? So if it is short, it has to be subtracted. That length is the erroneous length. For that we have to calculate the actual length, actual total measured length, right? So this is the thing you have to keep it in mind. Based on that only they are giving chain is long, chain is short. Next is the slope correction. I already explained. If the terrain is slope, we have used the chain or tape to measure from this point to this. We may think it is a straight, so it is a horizontal, but actually based on the terrain, this is the horizontal, but what we have measured is slope distance. Always the slope distance is higher than the horizontal distance, so here the correction is always negative and the error will be always positive, right? So that is the slope correction must always be considered and either eliminated in the field or mathematically compensated. That we have to consider. But here one formula is measured length into 1 minus cos theta. If it is possible to measure the theta based on some instrument, inclinometer or theodolite, we can use this formula. If it is not possible, I can get the elevation value of this point to this point. The difference between those elevation value del h or h can be utilized. That h square by 2l gives the error for the slope. Both the things are applicable, right? So consider this correction is always negative. Tension or pull correction. Here the tension is based on the applied pull or tension and the standard tension where the chain or tape manufactured. The difference between them into the total measured length divided by a modulus of elasticity of the tape or the steel. For the steel it is standard 2 into 10 power 5 Newton per mm square, and the cross sectional area of the chain or the tape, it will be given as the data. If you put all the things, you will get the error due to tension or pull. Here based on the tension it was mentioned as T. Here correction for the pull P minus P naught, the pull applied minus standard pull divided by AE into the measured length, here LM, here L. Both the notations are possible in different author books, right? But you have to understand the concept alone, right? This also the error may be positive or negative. If the applied pull is high, the error will be positive, the correction will be negative. If the applied pull is less compared to the standard, the error will be negative, the correction will be positive. Similarly, the temperature correction, the change in the temperature, in the field temperature minus the standard manufactured temperature. If the difference is denoted here as delta T, the temperature change, this may be also positive or negative. If the mean temperature is high, the error will be positive. If the mean temperature is low, the error will be negative, right? So based on this, here also the error, both the thing will happen. So the correction will be either positive or negative, right? Here here one more term alpha is the coefficient of linear expansion. How much a steel tape can be expanded? It has a standard value. It will be given in the data in the problem, or it can be assumed. We will see in further problem, right? And the last error and the correction is the sag correction. If the two person holding the chain or tape, it is in the air, so the catenary may form. So the slope of the catenary is the theta. If it is possible to measure, this formula is applicable. If it is not possible, we have to apply this formula, right? Since holding of the chain may vary from second to second, if it is available, possible, we can apply this formula, or we usually used to apply this. But this formula is both the same. I try to explain. Here the notation is small w into L. Here the small w represent the weight of the tape or chain per unit length. For 1 meter length, what is the weight of the tape or chain? Then if it is a 30 meter or 20 meter, we have to product it, that will give you the total weight. So w into the total length gives the total weight. So the total w, capital W, is the product of small w into L. That is the weight of the tape per unit length into the total length, right? So w into L, here the w square, L cube, so WL the whole square is again denoted by W square, and by T square, T represent the tension and P represent the pull, both are same, divided by P square, again they are combined here, and the 24 is same, and the left out L here is left out. Only thing, the cos square theta, here it is avoided or neglected, and the pull here we are using in newtons, right? So these are the notation you have to consider. This thing, the theta can be get from the angle of slope. The previously we have seen the slope correction, that theta, the same thing can be used, right, if we are able to measure. Otherwise we can go for it. So this correction is always negative correction, the error will be always positive, right? So slope and sag correction always negative correction, remaining all the things will have both positive and negative correction. So keep these things in the mind, and we will try to solve problem in the next video, right? Thank you.